writing code, especially under pressure. Maybe you're working on a high priority task that is urgently needed in production, might be a quick fix of a bug. We are very prone at that time to writing a very gibberish code. Those code that we look at them, as long as it works, it doesn't matter. If we are really honest with ourselves, sometimes we are aware of what we are doing, but we keep telling ourselves we shall clean it up later. But we know the truth, later doesn't always come. My name is Tracy Pendo Onim. I'm a software developer professionally for 5 years now, and today we shall go over some of the common mistakes that we developers make. The first common mistake is writing unclear or too general functions. These are the kind of functions that handles too many responsibility at once, and they're not clear of what exactly they're supposed to do. Let's look at an example we have here. In this example, we have a function called processUser, which takes in the user params. The user params can be something like the email, the first name, the last name, assuming that this function is involved in the registration of a user. What this function does, it first checks if there's an existing user in the database. If the user exists, it updates the user. If it updates successfully, it prints the message and returns an OK user result. Otherwise, if there's an error, it returns the error. If the user doesn't exist, it inserts the user into the database. If it inserts successfully, it prints a successful message, then returns the result. If it doesn't, it returns an error. The function works as expected, yes, but a lot is going inside that function. It has to check for existing user. It has to either insert or update the user. It has to print a message. It has to return the result. Now, imagine testing this functionality alone. Reading this kind of functions is very hard, and it gives the reviewers a hard time. Let's look at the second version of our code, processUser, that is more cleaner and more maintainable. Looking at this function, it's now very clear what the processUser does. It either creates or updates user. And if it creates or updates user successfully, it returns an OK user. Otherwise, it returns an helper. The create and update user function is another helper function, which has been written down. So this create user, it's the one that is now responsible for checking if the user exists in the database. If it exists, it updates. If it doesn't, it inserts. It's now very clear what each function does. Breaking down the functionality into smaller functions makes it easy to test, and also it's very easy to use this functionality without dragging any unrelated logic. And if you can see, it's very easy to read and to follow along what the code does. The second common mistake that we make is duplicating a code functionality. Have you ever found yourself copying and pasting a code functionality just because you need to add a small thing within the code? And you mostly do this because when you try to modify the original functionality, it either breaks or it does not support the new logic that you're trying to implement. Let's look at an example of a duplicated logic. The intent here is to create a user, an admin user, and a regular user. We have two functions that are implemented here. Create admin to specify that you're creating an admin user. Create a regular user to specify that you're creating a regular user. So both of the two functions perform, the intent is one, to insert a user with different roles. The difference between the create admin function and the create regular user function is the user struct that has been passed. So we have a user struct for admin with the role admin, and we have a user struct for the regular user with the role user. They both have chain set defined, and they both call the repo insert function. Just because we want to create users with different roles. Duplicating code will make your application harder to maintain. Imagine you want to add another user with a different role, say superadmin. Will you create another function just to support the new user? Let's look at a cleaner version of this. The intent is to create user with different roles. This function specifies create user with roles. It's a dynamic function which takes in role and params. With it supporting dynamic roles, it's easier to create a user with a different kind of role. So you don't have to add another functionality to support a different kind of user. Before you copy and paste the functionality, just because you want to tweak it a bit to support the new logic, first check if you can convert that function to be reusable. The third common sign of a bad code is implementing the logic without writing tests. I know this might sound like a small issue at first, but as your code base grows, it's very easy to break things within your application, especially when you need to add new features or refactor an old code. Apart from the documentation, personally I rely heavily on the test when working on an existing logic. It might be adding a new feature on the existing logic or refactoring the logic that is there. And this is because a good test has a comprehensive coverage of the functionality. It captures the edge cases that might be experienced. Tests are like a safety net. They should be there to help you capture bugs early enough before shipping to production. As you're implementing that logic, also learn to write tests for it. Another major red flag of a sign of a bad code is writing complex code. These are the kind of code that is very hard to understand and very hard to change. Here are some signs that your code might be complex. Writing too long functions or general functions that handles too many things within it, similar to the first case that we discussed earlier. Deep nested code. Let's look at this example. This is a function that handles requests. I'll give you a minute, go through the code and try to interpret it. I know, this is complex. Trying to read through the code is complex. This function has an if statement which checks if the request is authenticated. Inside the if statement, the request is authenticated. There's a case statement which is defined. So depending with the result of the fetch user, if it returns an OK user, another if statement is defined inside the case statement to check if the user is active. In Elixir, there is a with statement which will make your code much cleaner than having a nested code. Let's look at the cleaner version of handle request, which is using an with statement. This version is very simple and it's easy to read. Within the with statement, it checks if the request is authenticated, if fetch user returns an OK user, and if the user is active. If this result is positive, it does something. Else, it returns an error. The other way around this is breaking the function into other smaller functions. Writing a function with too many parameters. If your function has more than 4 parameters, that's a problem. If this function is being reused within your code base, it's very easy to interchange the values of the parameters. Here we have register user function, which takes 8 parameters. Basically, these parameters are the values that we are using to register user: the name, email, age, country, time zone, etc. If you're invoking this function somewhere, it's very easy to interchange the name, email, or the password, or the city and the country values. And this is one way of introducing a bug to your code base without even noticing. In this case, the best way to go about it is to group the related data. You can use a map or a struct. Grouping the related data with a map or a struct is now much cleaner. Now see, the register user takes in only one parameter, which is either the map or a struct. And also it doesn't matter how you order the fields within the map or the struct. The probability of you interchanging will be very minimal. Hard-coded values. Have you ever looked at a code base and wonder where this value is coming from or why this value is being used? It looks direct, but it's confusing at the same time. Here is an example. If score is greater than 70, what does 70 represent? It's not clear and it's more confusing. Have variables defined for such values, which clearly defines what the value represents. For example, in our case, 70 is used to check against scores. So you can define the variable for this value as passing score. That way, if you're checking for the passing score in more than one place, you can use the variable in those cases. And also, you only have 1 point to change the value if there's need to change. Let's look at a cleaner version of this. In this example here, we have a module attribute called passing score. The module attribute can be used in more than one function within the code base. So if you need to change the passing score, you don't have to change the passing score within the different functions that it has been used to check against. These are some of the signs of a bad code that have come across. Let's be aware of them and let's try to avoid them as much as possible. The easier it is to understand your code, the easier it is to test, to refactor, and also to grow your application with confidence. I would also love to hear from you. What are the signs of a bad code that you have come across? By the way, if you're writing Elixir, there's a very super helpful resource that you should check, the Elixir Anti-Pattern Guide. It points out the common mistake we make as developers and how to avoid them.